Dear students, let us continue our learning on the course Automata Theory and Computability. We are in the third session of the module 4. The topics covered under this session are Turing Machine, that is design of the Turing Machine. So in this video we see some of the examples for designing the Turing Machine. Myself, Dr. Suresha from the Department of Computer Science and Engineering of Canara Engineering College, Bantwal, Mangaluru. So first, for the design of the Turing machines, the basic guidelines for designing a Turing machine is given below. The fundamental objective in scanning a symbol by the read-write head is to know what to do in future. The machine must remember the past symbols scanned. The Turing machine can remember this by going to the next unique state. The number of states must be minimized. This can be achieved by changing the states only when there is a change in the written symbol or when there is a change in the movement of the read-write head. The basic principle in the design of the Turing machine is we need to remember the symbol. Let me take one simple example. Suppose I am going for a grammar language A power n, B power n. So in this case, I need to, when I go at the B, I should remember how many A's I have seen. That is, I should remember that one. The next one, as far as possible, I need to design the Turing machine with the minimum number of states. These are the two design issues. One is to remember, other is to design with the minimum number of states. For designing, there are two options will be there. Either we change the symbol, either we will change the symbol so that as if we mark that we have seen that symbol. We will change the symbol, or we change the state. We change the symbol and we change the state as if we have seen that symbol. So let me take simple example here. Suppose my language is A power n, B power n. For the A power n, B power n, let me take one example as a 3A's and a 3B's. So now this is an example for your equal number of A's and B's, that is A number of A's are 3 and the number of B's are also 3. So in this example what we will do is whenever we see A, we replace that symbol with the X as if we have seen the symbol A. Then we will change the state. So after changing the state, we continue in search of the B. Once we get the B, we will change that B to Y. Again we traverse back to get the next A. So once I get the second A, I will replace that A with the X. Again I will move forward in search of the B. Again once I get the second B, I will replace with the Y. Again I will go back in search of the A. Again once I get the A, I will replace with the X. Again I will go in search of the B. Once I get the B, I will replace with the Y. Again I will go back, but I won't find any A. Then it is the meaning that all the B's are also finished. If all the B's are also finished, means no B's, I will get only Y's. All the B's are also finished and next to that one will be the blank. If I am able to get my blank, means then I will go to the final state. Then I will go to the final state. Fine. So this is how we generally go for designing the Turing machine with these two things in our mind. One, we change the symbol marking as if we have seen that symbol. The second one, we change the state so that in the next state, that state we change means we have seen the symbol for that case. Fine. So these are the two options to know. So this is what the design of the Turing machine it will be. Let us take the first example now. So now in this example, I need to design a Turing machine that recognize all the strings consisting of an even number of ones. For us, the input is ones and the blank space. For us, the input is ones and the blank space. I need to have the equal number of ones. So if we go for designing a finite state machine for this one, if you remember the finite state machine for this one, zero number of ones is also an accepting one. So start state itself will be my final state. The next one, if we get in first one, then I will go to the next state Q1. Then next, if I go to get back the second one, again I will go back to the Q0. Here sigma is just 1, no 0 and all, sigma is just 1. I need to design my machine with the input symbol as 1. So this will be regarding your finite state machine, which we learned in the module 1. That is for even number of ones. The first one I will go to the Q1. When I get to the second one, I will go back to accepting state. Third one again to the Q1. Next, when I get the next one, I will go back to the Q0. So that the total even number, if we end in even number, then we end at the state Q0. If we end in an odd number, then we end at the Q1. If we end at Q0, means it is not Q0 means it is accepted. If we end at Q1, means it is going to be get rejected over there. Fine. If the same thing, if I want to go for designing a grammar, how it will be? First I start from the yes. So yes itself is my final state over there. That is yes derives epsilon, first option. The second one, if I get the first one, I will go to the next state, let it be t. So on the t, if I get the next one, I will go back to the yes. So this will be the grammar. So grammar for the even number of ones. Fine. So now these two concepts we already learned in our previous classes. Now already learned in our previous classes. Now let us go for designing the Turing machine for this one. Designing the Turing machine for this one. Fine. So now for designing the Turing machine, you take one simple example. Let me have the 4 ones or the 2 ones over there. I will start from the state Q1. For your textbook, they are starting from the state Q1. So the same thing I am continuing over here, Q1. Then next to this input will be your blank spaces. We already seen. Fine. So what we will do is first Q1 on 1. Q1 on 1 is nothing but Q1 on 1 is nothing but what? I need to move to one temporary state over here. I need to move to one temporary state over here. Let the temporary state be Q2. Let the temporary state be Q2. So do I need to remember this one? No need to remember, because that the state itself will remember the values. The state itself will remember the values. No need to remember this one. Then what I will do, I will change my state to Q2. This 1 I will replace with a blank space. 1 I will replace the blank space. The next symbol is on the right side. I will have the movement towards the right side. So what happens now? This 1 is replaced with the blank space. Then the state is Q2. So now I am in a Q2, means what? I have seen the first one. What is first next expected for me? The next expected for me is again it is I need to get what to get again one more one to make the things even. If I get one more one, then again I will go back to the state Q1. That is Q1 itself is my accepting state, and the blank and the right moment. Fine. So this is how. Now what happens? Now again the next one is replaced with the blank. That is a blank Q1 1. Again Q1 on 1, this one. Q1 on 1, what happens? We will replace with the blank and the state, change the state to Q2. Then Q2 on 1, again you replace with the blank and you will go to the state Q1 again. So once I will end, so what will I get? Q1 on blank I will get. So Q1 on blank means I will completed my transition. I can mark Q1 itself is my final state, or if you are willing, you can go to the state Q3 over there, indicating Q3 is in final state. It is left to you. But since in this case we are marking Q1 itself as a final state, the reason is quite simple. That is, we are not processing any epsilon and all over here. That's why we are taking the Q1. That is, Q1 means what? Zero number of ones is also a valid case. That's why we are marking the Q1 itself as the final state. Now if you look at the transition table which has been given, Q1 on 1, I will replace 1 with blank, change the state to Q2, make the moment right moment. Q2 on 1, I will replace 1 with the blank, change back the state to Q1. Q1 is for your even number. Q1 and make the moment to the right moment. So this is how that Turing machine will be designed. This is how the Turing machine will be designed. Then next, let us consider the next example now. In the next example, we need to have the concatenation. So this is designed for the concatenation. Sigma will be only 1. So what will be concatenation? Concatenation is nothing but joining. So we need to join two strings made up of ones. Let me have the first string over here. This is my first string. Let me call it as S1. Then the second string is my S2. So first string is a S1. So now what is the value of S1? S1 is we are having the double 1 over here. Then what is S2? S2 I am having the 3 ones over here. So now how it will be written? So I told it is a tape will be of infinite length. The tape will be of infinite length, that is on the left and the right ends we will have the number of blank spaces will be there. So in between that one I will have S1. So this is my S1. After S1 again blank space will be there. Then I will have the S2 over here. So now what I need to do? Now I need to concatenate. So concatenate means what? I need to join them end to end. That is the end of the S1 I need to attach S2. To the end of the S1 I need to attach S2. What is there at the end of S1? At the end of S1 I have the blank. This blank I need to remove. This blank I need to remove. How to remove this one? Again it's a question. So removing doesn't mean that we will take that one out. It is not like that. We have to change it. That's it. In the tape symbol cannot be removed. I can't cut the tape and I will take it out. This is not possible in your Turing machine. I need to change that one. I need to change the content of that place, of that cell, so in particular. So each unit of the tape we will call it as a cell. I need to change the content of that cell. What is the content of that cell? B. That I need to replace with 1, and the last B1 I need to replace with the B. So now what happens? Now this will be 1 1 S1. This B is replaced with 1. Again this double 1. The last one replaced with the B. So now the ultimately how it looks? It looks like as if we have concatenated over there. Right? So this is what the logic of the Turing machine. In the Turing machines, nowhere we are removing any of the symbol from the tape. It is not possible. The tape will be there. The tape contents you can change. By using which one? By using the read write head, we can change the tape contents. So that's what we are going to do. If you observe this example carefully, you can take any example. Let me take the S1 as 4 ones. S1 equal to 4 ones. And S2 I will take as 3 ones. S2 I will take it as 3 ones. Now I need to do concatenation. How I will write this S1? So S1 will be 4 ones. On the left of the S1 I will have the blank spaces. On the right of the S1 I will have the blank space. For S2 again I will have the 3 ones. On the left of the S1 again blank space is there. On the right of the S2 I will have the blank space. So now for concatenation what to be done? I will go for removing this blank space. Not removing, changing actually. I will go for changing this blank space in between which was there to the 1. Then I will go till the end. I will go till the end and the last one I will change it to blank space. So that will do my concatenation. This will be written as it is 1 1 1 1. This is written as it is and this will be changed. So how we can do this one? The simple logic. Let us go with the simple logic. So how we can do this one? First we start up from the Q1. Q1 is, let me take the Q1 as my start state. Q1 on 1. So this is for processing this S1. This is for processing S1. Do we change any ones of the S1? No. We have retained them as it is. We have retained them as it is. How to do that one? We will retain everything as it is. Q1 I will retain as it is. 1 I will retain as it is. But I will have the right moment. But I will have the right moment. That is, this will process the S1 string. That is my first string. So what I have done? In the Q1, whenever I will get the 1, that 1 I will retain as it is. Q1 I will retain as it is. Just I will make the right movement. So now what happens? So initially let me take this example 1 1 1 1 blank and the 1 1 and the blank. So I started from here, right? So Q1 on 1. What I have done? 1 as it is, Q1 I have shifted to the right side, then the rest will be 1 1 1 blank and the 1 1 and the blank. Again Q1 on 1 Q1 is shifted. Again Q1 on 1 Q1 is shifted. Again Q1 on 1 Q1 is shifted. So now in this scenario, what will I have? 1 1 1 1, then the Q1, then the blank, then the 1 1 1 and the blank. So now this blank, what to do for this blank? What we are doing? We are changing that blank to 1. We are changing that blank to 1. That is my next step. What is that one? Q1 on blank, I will change that blank to 1. So what about this Q1? So now do we have processed S1? Yes, we have completed S1. Now what I need to do? I need to process S2 over there. To process that S2, I will change my state to Q2. So Q1 I am using for S1, Q2 I will use it for S2. Then I will have the right moment. Then I will have the right moment. Again, Q2. So now this blank is replaced with 1. The state is Q2. So Q2 I will keep on moving. I will keep on moving. Q2 on 1. What to do? Go as it is. Q2 on 1. This 1 will be retained as it is. That is Q2 on 1. I will change. I won't change anything. Q2 as it is. 1 as it is. But I will have the right moment. I will have the right moment. That is a 1, this will be retained as it is. Q2 will move to the next location. Again move to the next location as it is. Then again 1 as it is. Then once I get my blank, indicating that the previous one I need to make it blank. That is, once I reach this position, what is the position? Is a Q2. Once I get the blank, once I get the blank on Q2, meaning that I have reached the end of S2. I reached the end of my S2. What to do? That I need to go back to that previous character and I need to make that 1 as, I need to make that 1 as blank. That I need to do. The same thing we are doing. So here you can see the last one I need to replace with the blank. The last one I need to replace with the blank. To decide that last one, what is the next character of it? That is a blank. So once I get my blank, then I will change my state to Q3. This blank I will retain as it is, but I will have the left moment. So a left moment means what? Now I will come over here in between here. So now here is my Q3. So now in Q3 what to do? So Q3 I need to replace my Q3. I need to replace my 1 to the blank. So that is a Q3. I can go to my final state Q4. Then this 1 I will replace with the blank. Then I can have the left moment or the right moment. It is a left to you. So once you go to Q4, means you are done your attaching. That is concatenation is done. Concatenation is done. This is the basic principle before the working of the Turing machine. This is the basic principle in the working of the Turing machine. Fine. So now let us look how we are doing over here. Fine. Simple logic. They are starting from the Q0. Q0 is for processing your first string S1. First string S1. Q0 on 1. I will keep on moving. 1 as it is. Q0 as it is. Have the right moment. 1 as it is. Q0 as it is. Have the right moment. Then once I get the blank, means I reached Q S1. Then that blank I will make it as 1, then have the right moment. Now I am using Q1. So Q1 is processing the S2 over there. So once I am in the Q1, if I get the 1, I will keep on moving. Once I get my blank, means I reach the end of S2. Now what I need to do? I need to move to the left side, and the left side symbol I need to make it as a blank. Fine. That is what I will do on blank. That is Q1 on blank. Blank as it is. Left movement. I will change the state to Q2. In the Q2, what I will do? The next one, the last one of S2, I will replace with the blank. Then the left movement and change the state to Q3. So once I am in the Q3, for all the ones, I will just return 1 as it is, left as it is, and the Q3 means I will come back till the beginning over there. Till the beginning of the string, I will come back. So what the beginning, what I have? Blank. Blank, then the right moment, then change the state to QF. So that is QF is my final state, that is QF will be my final state. This is how we go for designing the Turing machine for concatenation. This is how we go for designing the Turing machine for the concatenation. Fine. I hope it is clear, and if you have any doubts in this one, we will clear those doubts in our online classes. So these are the examples for the concatenation of the Turing machine. Fine. So you can observe here Q0 on 1. I will do 1 as it is. Q0 I will have the right moment. Q0 on 1. I will have the right moment. Q0 is here. Q0 on blank. That blank I will replace with 1 and I will have the right moment. Change the state to Q1. Q1 on 1 right moment. Q1 on 1 right moment. Q1 on 1 right moment. Then next Q1 on blank. Next this blank I won't do anything. I will shift my position to left side. Now the change the state to Q2. Q2 on 1. This one I will make it as blank. Then I will have the left moment. So in the left moment I will go till the beginning. Then Q3 on 1 just left moment. Q3 on 1 just the left moment. Q3 on 1 left moment. Q3 on blank means I reached the end. Once I reach the end, I will change my state to QF. QF is my final state. So this is how the concatenation will be done. This is how the concatenation will be done, and this is your instantaneous description for the concatenation. The references for this presentation are taken from the textbook KLP Mishra, N. Chandrasekharan, 3rd edition, Theory of Computer Science, PHI 2012. Thank you.